Oh, hey, are we live? Let me do a rain check. Is it called a rain check? I'm just testing it. Hmm. Is my mic on? Test. Okay. Test. Test. Okay, I should be live. Welcome to another tech day with me, yours truly, coming straight to you from my workspace slash bedroom. In the last one, I started working. I actually finished ridge regression, which is a way of optimizing linear regression workflows and linear regression models. In the same way, I'm gonna continue with the lasso regression now. Okay, lasso regression. Let me do a quick Google search because the book I'm following is, again, as I said, not very reliable in a sense that it doesn't teach these concepts properly to beginners. That's here. This should be the link. Lasso regression. I don't like this page. Also, it's IBM's official, so I don't like it. Double. I don't know why. I'm nothing against IBM. Lasso regression simplifying. Maybe this is a good one. Okay, imagine you're packing for a hiking trip. You laid out everything you think you'll need. Is this AI generated? It most probably is. It 100% is, but sometimes AI teaches better than real people. So imagine you're packing for a hiking trip. You laid out everything you think you'll need, from essentials like a water bottle and sturdy boots to extras like a novel and your favorite snacks. But as you pack, you realize your bag is getting too heavy. To make the hike manageable, you decide to take only what's absolutely necessary. So what's necessary here? I don't need the cigarettes. Also, why is my man taking 2 books? 3 books? What's this? Is this a book as well? But yeah. In machine learning, lasso regression works like that smart hiker. It identifies the most important features in your data while trimming away the less useful ones. So lasso regression adds a penalty for complexity. Okay. Same problem we faced in the ridge regression video. Overfitting. Too many features in order to get better predictions, we should reduce the amount of features, right? Yeah, and especially those who are predictive, like proximity to school is relatively, I don't know why it's highly predictive, maybe relatively predictive. Like others, like color of the mailbox, add noise and are unnecessary. If your model tries to use all these features, it might overfit the training data, performing poorly on new data. Wait, let me put this on this side. And let me put you on this side. Okay. Yeah, overfitting happens when a model is too complex. I got this the last time, and as I repeat it, it becomes more and more clear on what it is and how it happens. Or, yeah, when a model is too complex, it captures noise instead of meaningful patterns. Lasso regression helps by shrinking the coefficients of less important features, sometimes even reducing them to zero, effectively removing irrelevant features. How lasso regression works. This is a nice article, actually. Even if it was written by AI, it's a nice article. Maybe it wasn't, but I hope it wasn't. I mean, even if it is, it's not a bad thing. How lasso regression works. A lasso stands least absolute shrinkage. I use this operator in Photoshop. I didn't know that. Is this even the same thing? The lasso operator from Photoshop? Maybe not. Lasso stands for least absolute shrinkage and selection operator, like ridge regression, which I did in the last video. It adds a regularization term to the loss function. However, while ridge uses the sum of squared coefficient, lasso uses the sum of the absolute values. Now, I'm the kind of guy who learns these concepts by knowing why they are different. I would like here to be I don't know, maybe an explanation on why ridge regression uses one regularization method and lasso uses another, but okay. So this is the formula, which I'll most probably forget. This is the sum of squares, lambda. Lambda is the param that we also had in ridge regression as well. Lambda is the regularization parameter, and the betas are the feature coefficients. The absolute value penalty lasso has a unique property. It can shrink some coefficients to exactly 0. This means lasso performs both regularization and feature selection. Okay. If anyone is watching this, basically what I'm doing right now, I'm covering a concept called lasso regression, which is an additional regularization method for polynomial regression. Basically, what I'm trying to do here is to find the best way on how to solve a polynomial equation. And that polynomial equation, if you remember from school, is maybe oh I have here a polynomial. Where's my tablet? It's here. I wrote it here somewhere. I remember this clearly. Ah, yeah, this is a polynomial. This is an example of a polynomial. No, I didn't want to delete this guy. Of a polynomial equation. So basically, I'm just trying to understand how to solve polynomials using polynomial regression and then using an additional step of lasso regression. And I'm a complete beginner, so most of the things that, if you are watching this, if this is simple to you, keep in mind I'm as green as they get. So yeah, lasso is like a method that helps us solve these polynomials easier and faster, and that's it. That's like the explanation, the least amount of words. Imagine you're sculpting a block of stone into a statue. At first, the stone has all kinds of rough edges and unnecessary chunks. As you chip away the shape of the statue emerges, lateral regression works similarly, sculpting your model by removing features that don't contribute much to the predictions. By shrinking irrelevant coefficients to zero, lasso simplifies the model, leaving only the features that matter. Yeah, this makes sense. As a complete beginner, basically, you're buying a house and you have these plethora of different features. Like, I got some kind of notification. No idea what's this. Grandpa leaving me millions. I don't care, Grandpa. Bye. So you're buying a house. Yeah, you're buying a house, and you have this data sheet, and you have all these features like the street name, the average, I don't know, salary in the neighborhood, if you have something like this, blah 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 blah. And there are some features that are better for prediction than others. Like in the article here. Why do we care what is the color of the stupid mailbox? The balance of lambda, the regularization parameter lambda, determines how much penalty is applied. With a bigger lambda, we have a strong penalty. More coefficients are shrunk to zero, resulting in a simpler model. And with a small lambda, weak penalty, coefficients remain large, leading to a more complex model. Okay, and here is a practical example. I'm gonna do a practical example of my own. Okay. Okay, so the only difference between lasso, and I'm sorry if I'm repeating this often, this is just how I remember. So the difference between lasso and ridge is that lasso can shrink some weights all the way to the zero. And it, by association with this, it automatically ignores unimportant features. Bum, 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 bum. Okay, let's do a simple example. Let's do a simple example before even starting this. I just need to run all of these cells above, and I need to copy the input here. Okay, has everything been run? Yes. Okay, what's our goal? What do we want to do? Like in we want, and this is the gist, we want to predict y, whatever y is the price of a house, the possibility that the movie is gonna win an Oscar, the possibility that your dog in the betting house comes first, whatever. Predict y using multiple features. And watch how lasso eliminates the useless ones. So the specificity for this is that lasso removes useless ones. Let's check. I'm doing another check to see if I. Okay, I'm running. I'm running. So lasso removes useless ones. Okay. So what I'll do, I'll use a tiny set with the 3 features. Okay, x is numpy array. Okay, 1 0 0. Give me the second one. 1 2 3 4. What? I haven't selected all of this. 1 0 0 2 3 4 5. Of course, I won't keep this data here the same. Just a second. Here I'm gonna have 2. Here I'm gonna have 1, not 10, but 1. Here I'm gonna have 3. Here I'm gonna have 4 and 1, and here I'm gonna have 5 0 5 0 5 0 1. And now let's also have the target values. NumPy array 2 4 6 8 10. So what this is basically, I have x1s, x2s, x3s, and y's, and x1 is 1 0 0 because the first row in the NumPy array is 1 0 0, and the solution for this is 2. And then we have 2 1, and the solution for this is 4. Then I have 3 0 0, the solution for this is 6. The next one is 8. The next one is 10. We have 4 1 0 and 4 5 0 1. And now, I need to import another model. I'm gonna import the usual linear regression model with no regularization, no optimization, nothing. Linear regression. And now I'm gonna create the linear regression model. It's gonna use the linear regression, whatever this is. Reg fit x fit y. X just for some reason the standard is to have x in uppercase. I have no idea why. So print coefficient will be linreg coefficient. Print intercept will be linreg intercept. Save and run. These seem like they are not correct for some reason. So this number shouldn't be like this. Why are you like this? Why are you like this? No, this shouldn't be like this. Why? 1021 30 501. Ah, okay, I think this is actually correct because this number right here, let me just check. What is this number? This is just a regular number 2. This is just a regular number 2, but the other numbers, for some reason in lasso regression, are not important. I still don't know why, and they still exist. So the problem is that linear regression gave some weights to x2 and x3, even though they are useless. Ah, this makes sense. So if y is 2, so I'm gonna have y is y is 2x1 2 times x1. Okay. Now let's also call the lasso regression. Model lasso regression will be lasso. It's only lasso. So alpha. The other guys are called ridge regression or linear regression, and lasso is just lasso. 0.1 lasso regression fit for x and y. I'm gonna do the same thing here, only this time without the linear regression. I'm gonna use lasso regression, and if I run this, I killed all the coefficients here, and my intercept changed a bit. But why? What's the mathematical reasoning behind this? The mathematically lasso will, because lasso knocked out x2 and x3 from here. Lasso knocked them out because the cost of keeping their weight isn't worth a tiny gain, so it dropped them. And then lasso will probably predict on the next data. Basically, if you're making a delicious late night snack. You're the chef, and if you look at the sandwich you are making and you see something you don't like anchovies, you're gonna say, okay, this guy doesn't improve this, I'm leaving it out. And that's how you get a cleaner and leaner model. Now, this was the most simple example I could find, like the simplest, most basic example of this I could find. So the rest of this code is something that is picked straight from the book, and I'm gonna try and break it down and understand it. Okay. I also understood right now why only the first row is important. Wait, look at this. Look at this. No, thank God. So let me pick another one. It's not about solving the polynomials, it's about finding the relationship between them. And in all of these rows here, we have one pattern that is being repeated. And you know what is the pattern? Is that every y is 2 times x1. So at this point, we don't even care how related to x2 and x3 y is, because we know that it almost perfectly utilizes only x1. Only x1. In every one of these examples, y is 2 times x1. And even when x2 or x3 is 1, it doesn't affect the target. It doesn't change the output at all. So they are just extra data that do nothing there. They do nothing. Now, why linear regression assigns weight? I think it has something to do with the method, the error minimizing method linear regression uses. But Lasso doesn't use it. It says, okay, if this feature isn't clearly helping, I'm cutting it out. Interesting. So what do we have here? This is the example code. This is the real code. I'm gonna delete this, or maybe I should just comment it out. Yeah, let's comment it out, and let's run again all the cells about. A bird just hit my window. A bird just attacked me. Okay, so can I run you now? I can. Same thing. I pulled lasso. I have this x and y list of inputs, and the output. The lasso regression just fits it on this data, and then it tries to predict another one. For 1.5, what should I get? I get 2.65. I even forgot what the data is. I think something randomly generated here all the way at the beginning, right? Yeah, it's something randomly generated. Just 2 times two times some random noise for x, and for y it's 4 plus 3 times x. So we get this line here. But this is the linear regression. I don't want the linear regression, my brother. I want the polynomials. Here they are. Here they are. So it's something similar to this. Yeah, it's x is again a randomly generated number, and y is same thing. So I'm using these same inputs right here, the same data. Okay, so I predicted for 1.5, I predicted 2.6533. But let me just make sure. This is what I'm working, that this is the data I'm working with. Yeah, this is the one. Wait. What do I have? I have x to be, is this, no, this, what axis is it using? Ah, but this data is really noisy. That's the problem. I thought I could maybe create a simple example in which I say, okay, if x is 1.5, then I could do y here, but it has a lot of noise. I don't think it would. I don't think. What have I done? Why am I pulling this? I don't think it would amount to nothing. So let's go back. Okay. What is the book saying? Okay, the book mentions lasso regression. Gives me the mathematical definition of the cost function. It's a really complex one. It uses already the mean squared error, and it does some extra work with it, which I don't think it's important now. So here we create two subplots. One model is plotting lasso, the another one is plotting lasso as well. I thought it would compare between lasso and ridge, but it didn't. Yeah, same thing. Same thing as ridge regression as well. Now look at this fat boy here. Look at this guy. Oops. This big cell generates and saves figure 419. So what are we doing here? Okay. Mm, 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 mm. T1A, T1B, T2A, T2B, T1S, T2S. Okay, so this just creates, pardon. So this just creates a grid, am I right? Yeah, nothing more. So minus T1A, T1B, T2A, T2B. And then we create a mesh grid, which is, I assume, this right here. What is this doing? What the hell, man? What's this? It's like suddenly I thought I understand all of this, and then I get these things. What is the Ravel, man? What is this doing? Okay, I get this creates a list of properties, and it creates a mesh grid of these properties. What is the C doing? NumPy.c. What is this? What is the T1 Ravel? Wait, let me check. Let me look at the conjunction. I'm stuck right here. I'm stuck right here because I don't know what the C does. I don't know what Ravel is either. Okay, so it says this line takes two two-dimensional arrays. T1 is a two-dimensional array, and T2 is a two-dimensional array. And it creates a single two-dimensional array T, where each row is a pair. Combination of theta values. Wait. I got it. Print T1. Print T1. Okay. What if I want to print only the first element of T1? Only that. Okay. All of this is the first element of T1. And what if I print T? Why do I need to scroll all the way here? And the first element of T is what? -1. How? I mean, I understand that it reduces these arrays, but how? How? Okay, I understand. For example, this right here, T1 and T2. To T1 is a 500 by 500 matrix, where each row is a copy of this. And T2, same thing, only each row is a copy of this. No, I mean, it flattens. It flattens this. It does something with it. I don't understand how. I don't understand. Okay, let's do an example. I work best with examples. I do best with examples. So where's my tablet? It's here. Let's say I have this here. I have wait. Use pink. I have T1. S is numpy array of 10 and 20, and the same thing here. It's a numpy array of 1 and 2. Instead of having, as we do here, 500 by 500, we're gonna have all 2 elements only. So here I have 2 values of theta 1, and here I have 2 values of theta 2. And then I create a mesh grid here. So T1 will be a big one is gonna be 10, 20, 10, 20. Same thing with T2, 1, 2, 1, 2. So each pair of T1 ij and T2 ij's are coordinated on the grid. So I need to flatten these. So after I do T1 Ravel, what am I getting here? I'm getting 10. Oh no, I made a mistake. Sorry, because I'm flattening it. I'm not having a 2-dimensional array. I only have 10, 20 because I remove all of these borders, array borders, and I'm gonna have 10, 20 again. And T2 Ravel is 1, 2, 1, 2. Okay, so each index corresponds to a point on the grid. Now, I have T1 and T2. I have this here. This part. So now, what is the C doing? C is combining them into coordinates. Okay, I have T1 Ravel and T2 Ravel. And now when I combine them with coordinates, so I assume that C means coordinates. I'm gonna have the big T will be 10, 1, 10, 1, 10, 1, 21, and 10, 2, 22. So each row is a pair of thetas, and I assume they are not duplicated because it would be 10, 20. It's gonna be 10, 2, 22, 10, 1. So I assume the extras are being removed. Okay, so this basically means, okay, I have 2 sliders. I have oh, how have I created this line suddenly? Am I just holding it? If I hold it, I get a straight line. Good to know. Okay, I have 2 sliders. I don't know. What could it be? Let's say the hue of an image and I don't know. What else could I? The side of an image. So I want a green, blue, and red image, and I have small, medium, and large. So I want every one of these combinations to be here in this grid, and I have these combinations right here by using this unnecessarily complex method. So what's the next one doing? What is the next line doing? Oh god. What helps this? Okay. Now these two, okay, these two lines are just creating a data set with 3 data points and 2 features. Okay, okay. I was so confused for a moment there. Basically, let me just move here. Basically, I just have XR, which is an NumPy array of 1, 1, 1 minus 1, 1, 0, 5, and the same thing for y. It just creates data out of these out of the original XR. So this is a 3x2 feature matrix. This row is gonna be 2 times what every value for x1 plus 0.5 every value for x2. Is it? Because x1 is 1, x2 is 1, x1 is 1, x2 is minus 1, 1 minus 1. What this does is that it selects the first column and keeps it in a column shape. So it's gonna take 1, 1, 1. And this one is gonna take the second column, is gonna take 1 minus 1, 0, 5. And then after I calculate this, I'm gonna have all the values of y. What is the next line doing? What are these all? What is this? What is this? What is this? So this is just a formula for is this just the main squared error? It's 1 over the length of XR. Yeah, it's just the regular main squared error here. Yeah, okay, this is just a formula for mean squared error. I don't want to go too deeply into the math, but that's it. What else do I have? Length of XR, but the length of XR is only 3. linear, what's this? A linear algebra function. So what are these? Are norms. And then I do this. Fuck man, look at how long this guy is. I mean, this here is simple. It just draws these guys, but ridge and lasso. Compared to penalty most probably. What's up? What's up? I'm not building anything actually. I'm trying. For some reason, I decided to learn about this concept of lasso regression, which optimizes polynomials, solving polynomials. I mean, it's completely unnecessary. It's extra knowledge, and I don't know why I'm doing this. To be completely honest, but I don't know. Seems interesting. I don't want to go too deep into this. But I'm gonna do some, I installed Unity, and as I said, my dream is to make my own game one day. So today, officially, after I finish this, and I'm already tired of it, I'm just gonna take a quick break and I'll do Unity like from scratch. Being the biggest idiot ever, I never used anything. I actually did use Blender for a while. Okay, but you most probably don't care about this. You want to see me struggle with this. Why is... Okay, let's do another example. Let's go through this. So again, T1s and T2s, blah blah blah. I don't care about this, but basically what T1 does, it creates... Okay, let's say I have a T1. I have 0 0 and 1 0. T2s is 0 0 and 1 0 as well. Instead of having these 500 grids elements, we have only 2 elements here. Now I create a mesh grid, which means that just now duplicates all of these. It's gonna be again 0 0 1 0, but because I created a mesh grid, it's gonna be 0 0 1 0, and T2s will be the same because it has this data, and each estimation is one possible combination of this. Next thing, flattening and combining. It's this line right here. It's this line right here. So I'm flattening my two-dimensional arrays because they are the same. I'm just gonna do example on one of them. We will have 0 0 1 0. Again 0 0 1 0. I just removed one extra layer here. I just removed one extra layer right here. But now if I want to do a coordinate, I'm gonna have here the same thing, because T1 and T2, let me put another color, are consisting of same data. So now I'm just combining each one to create a combination of every example here. So I'm gonna have zeros. Wait. I'm gonna have, what am I gonna have? 0.0 and 0.0, because this is the first combination here. Next one will be 1.0 and 0.0, because this is the combination. The next one will be 0.0 and 1.0, and the next one will be 1.0 and 1.0. So I combined all of these. I removed the duplicates because I can have 0, 0 here and 0, 0 here, but I'm removing the duplicates. So I have these 4 pairs, and we're gonna evaluate our theta on these 4 pairs. Now, let's do XR and YR. XR is, let's do a really tiny data set, and we're gonna create this NumPy array. It's gonna be consisting of 1, 1, and 2, 2. What are the x1s here? The x1s are the first numbers. They are 1 and 2, and x2s are 1 and 2. Again, what then? Let's say my formula is 2 times x1, 2 times, I don't want it to look like x prime, 2 times x1 plus 1/2 x2. And then I use this JR method right here just to extract x1s and x2s. So basically x1s will be, as I said, 1 and 2. X2s will be, as I said again, 1 and 2. I'm duplicating data because it's simple to work with it. So what is then JR is 2 times, right? 2 times 1 and 2. Wait. 2 times 1 and 2 plus 0, 5, 1. I don't know why I'm writing the decimals. I apologize. 1 and 2. Okay. Okay, so this will then be, because I'm multiplying, so I have, what's this? This is 2, this is 4, this is 0, 5, this is 1, and then I'm adding those numbers. So I'm gonna have 2 plus this one here is 0, 5. So I'm gonna have 2 plus 0, 5 is gonna be 2.5. 2 times 2 is 4, plus 0, 5 times 2 is 1. I'm having 5 here. Apologies. Hey Ashad, actually I'm following a book, and this code I think is free of use completely. So if you want to take a look at it, the book name is Hands-on Machine Learning with Scikit-learn, Keras, and TensorFlow, and the code is completely free. I'm also having the book, but I don't know the legality of showing it, even though it's mine. So yeah, I could push it to GitHub, but you have everything there already. So maybe that's better. Also, yeah, this is really complex. I also started machine learning maybe half a year ago, but I was really sparse with my learning, so I would forget most of the things. Now I'm on a roll, I think, for maybe 9 months. I studied 20 days, so I had a really good roll going. I was on fire, and it's a lot easier, to be honest, to understand this when you have this short-term memory that you can rely on. I'm also I don't know. I'm starting to because this shit is so annoying. I'm thinking of skipping this and doing the exercises. Yeah, the next stream I will most probably do the exercises. So if you guys are around, please join me because we are going to do them from scratch. Exercises from the book, that is. But let's finish this. Let's finish this. Oh, I just need to get some water. I'm really sorry. I'll write here BRB. BRB, guys. All right, I'm back. Is my mic working? Okay. Yes, it is. It is, it is, it is. Also, why is my computer so loud? It's burning basically. Okay, where did I stop? Yeah, I found out the values of both XR and YR. And then I need to compute this formula right here, which I don't have the nerves to do this. But let's try just to decode it. What is the T? I think this is the T. For some reason I always forget to label them. This is T. Is this T? I think it should be T. Yeah, this is T. So T has the shape of what? We have 4 elements. 1, 2, 3, 4. Each one has 2 elements of its own. So the shape of T is this, only the shape. It's not the solution. The shape of T is 4, 2. The shape of XR is 2, 2. The shape of XR transpose is again 2, 2 because it's a 2-dimensional matrix by 2 dimensions. Even if we split it around, it's going to be 2 by 2. So T multiply, I think this is the matrix product, I think, will be 4, 2, which is going to be the prediction for every combo on every training point. But every combination for every training point that we have is going to be 4, 2. Then I subtract the shape of YR of T. Wait, let me do another example of this. So if my theta is, this is just one example, 1, 0 and 0, 0. So what will my prediction be? It's theta. I'm doing a multiplication with XR transposed. What am I gonna have? What's my XR transposed here? is my first number of here with XR and the second number here with XR as well. This is gonna be okay. Once I find a theta, like 1 and 2, I have my solution, which are the true y's. It's gonna be 2.5 and 5. Then I calculate the difference to find the error. The error is gonna be 1.5 because I need to subtract 2.5 from 1 and 5 from 2. The errors will be minus 1.5 and minus 3. Then I need to square those guys. This is gonna be 9. What's this? 15, 220, 225. So this is the squared error. Squared error. And the MSI will be 1/2 because I have only 2 elements in my dataset. Multiplied by 225 times 9, I'm getting the error of 562. And then afterwards we come here where I normalize these two solutions. Just a second. All right, so these are just 2 ways of normalizations. Oh man, I think I'm gonna skip all of this. Fuck. I understood the first 5 lines of code, like, and then I saw that there's 50 other lines. I said no, not today, sir. There's another regression. It's called elastic net. What's early stopping? Okay, early stopping. This uses another dataset. What's this? This is a quadratic dataset. Okay. I should have skipped all of these tiny regression models. I don't think they are needed for now. I don't know why I did this. Okay, decision boundaries, softmax regression. Oh, okay, these are the solutions to the exercise. I won't do the solutions because I want to do at least one exercise here. Let me increase this and let me ask the question for the exercise. So the first question says, which linear regression training algorithm, I'm just gonna put algorithm, can you use if you have a training set with millions of features? If you have a training set with millions of features, which linear regression training algorithm can you use if we had? So this isn't even from these last couple of episodes. This is all the way at the start. I think we used a linear regression. Yeah, there's the normal equation. Now, why can't we use ridge regression? because linear regression does really exhaustive exhaustive matrix multiplications when it tries to calculate the error. I know this. Also, I can't use lasso, so I need to use something really simple, I think. I mean, simple, quote unquote simple. And I know just right, and I know the right algorithm for this, because I remember. Wait, where's there's this example. I think I did it already. So it doesn't write it here, but I think the correct answer for this is, if you have a training set with millions of features. Yeah, I wanted to say, I said my answer. I wanted to say stochastic gradient descent, because I know that the stochastic gradient descent is an optimization algorithm that updates only randomly selected training examples at a time. So the answer is SGD. I didn't know about the other ones. So basically, when we have millions of data, we don't want to solve a huge system at all. We want to take them down step by step. Okay, is there another question? So there's 11 theoretical questions. I'm gonna do all of these 11 theoretical questions. Have I said I'm gonna do all of the 11? I won't do all of the 11. I'm gonna do a couple of them, but I'm gonna finish all of them, put them behind me. So the next stream, I'm gonna do a real example from all of these topics that we had here. No. Oh, okay. So there's another question. There's another question from the book. Okay, we are using polynomial regression. Polynomial regression. We plot the learning curves like we did, I think, polynomial regression. Where are the learning curves? These are the learning curves. So we plot the learning curves and we notice where are you? We notice that there's a large gap between the training error and the validation error. We notice a large gap between train error and validation error. Why? What is happening and how can we solve this? So where's my polynomial? Polynomial regression. It's here. It's here. It's here. Is this it? No. Learning curves. Yeah, this is okay. We are having polynomial regression and we plot the learning curves. So these would be the learning curves And we notice that there is a large gap between the training error and the validation error. We have the training error, we have the validation error. So what's happening and why? What is happening and why? It's overfitting. I remember this. I don't know why exactly. Let me just try to find this. Because if we have a gap here, wait, where's another one? So we are most probably overfitting here. Where's my? We are overfitting. We have a lot of polynomial degrees. The data fits. It fits the training data too perfectly, but I remember talking about this. On new unseen data, it fails to generalize as it should, which means that we have a lot of features that are being used. So we have, how can we fix it? So we need to reduce what? The degree of the polynomial. So I need to simplify the model. And how can I simplify the model? I could use one of the regularization linear models. Yeah, I could use one. Is this the answers? It was the question number 8. If the validation error is much higher than training error, it's likely because the model is overfitting the training set. As I said, one way to try to is to reduce the polynomial degree. A model with fewer degrees of freedom is less likely to overfit. Okay, another thing you can do is to okay, so this is one solution. I only mentioned the second one. Okay, I can regularize it. So is there another example of you can try to increase the size of the training set? I didn't know about this. I didn't know about this. And oh, there's another really cool question. Wait. So yeah, right here, overfitting, and the solution is there are multiple solutions. So increase training set, use regularization, or reduce the degree of the polynomial. Okay, and another question. The last time I'm gonna finish machine learning with this question. Okay. The question says, why use ridge regression instead of plain regression, plain linear regression? Okay. Why use ridge regression instead of plain linear regression? Why use lasso instead of ridge? And why use elastic net instead of lasso? First of all, I have no idea what elastic net is because I skipped that part completely, but I know why we would use ridge regression instead of plain linear regression to reduce overfitting, because ridge regression adds error penalty. Why would we use lasso instead of ridge regression? So we want to automatically eliminate what we don't. We want to automatically eliminate coefficients which are not needed or not actually not needed, useless. So basically this will shrink some weights Am I true? A model with some regularization typically performs better than a model without any regularization, so you should generally prefer a ridge regression over plain linear regression. Okay. Lasso regression uses a penalty which tends to push the weights down to exactly 0. This leads to sparse models where all weights are 0 except for the most important weights. Which I said actually. I said they are, it removes useless coefficients. Which is good if you suspect that only a few features actually matter. When you are not sure, you should prefer ridge regression. And elastic training net, I didn't go over this, so I don't know what it is. Nice. Okay, I'm done with machine learning. The next live stream on machine learning will most probably deal with a real data example. We're gonna do a real problem. In the next one. And right now, I'm just gonna get some water again. And I'll do some Unity. There are four people watching this. I don't know if the Unity stream will be interesting at all because I'm a complete and utter like noob. But if you want to watch it, please be my guest. I'm gonna be back in 2 minutes. I am back. I'll just set up everything for the Unity. I'm just gonna set everything up, make it nice and cozy. I'll close this. I'll close this and can remove all of this. Let me open Unity Hub. Okay, I'm gonna create a new project. Let me just remove my tablet for now. Read the chat. Oh man, sorry. Sorry, it seems like my chat bugged out. Oh man, guys, I'm really sorry. I'm really sorry, guys. Fuck. Why is this bugged out? I was looking at it from my phone. Ah, shit. I was doing some machine learning, and in the next stream, I'm gonna do an example. We're gonna implement a machine learning algorithm of its own. Yeah, then I'm gonna do some game development, but to be completely honest, I'm as green as they get. I'm a complete noob. I don't know anything about this. If you want to watch, please do. I don't think if you know anything about game development, I don't think what I'm gonna do right now is gonna be interested for you guys. But yeah, keep on watching if you want. Yeah, I'm having like a tutorial on my other screen, so I'm following it uh, together with this. Again, I'm a complete noob when it comes to this. Okay. Shit, how am I bugged? How am I bugged, man? I apologize for not reading the chat. I'm really sorry. Shit. Okay. Video games. Thanks, man. Oh, man. Thanks. I appreciate it all the time. XS Dragon XX. I will watch. I was wanting to. Yeah. I always back down when I hit. Thanks, man. The only way I still have motivation to learn, uh, in university, I think most of you guys are a bit younger than me. I finished my university how many 3 years ago, so I'm already working, and during university it was a lot easier to find time to learn because you are surrounded by people who are doing the same thing you do. Like you go to the university together. But now I don't have a lot of free time, so the only way I can learn is basically by streaming, having the obligation to I don't know, produce my thoughts to the world if someone is interested in them, even though I'm not particularly smart. Yeah, no, actually, the goal of this channel is to show you how someone who is not really smart, like I am, can learn all of this shit on its own. Yeah, that's the goal of my channel. Actually, I'm not that stupid. I'm stupid on average. Okay, well, how many versions of Unity? Okay, I'm 20. This is my first year in uni. Oh man, I would wish I was 20 again. The best years. Not studying CS or any IT related. Maybe I want to learn this as a hobby. Yeah, it's great. I think programming tickles your brain in different ways, especially different flavors of programming. I make my own game. Man, now is the best time to build your own game. Like the best time. I don't like AI, but you can generate a lot of assets and models with AI. And basically the only thing you need to do is to put all of these assets you have together and produce something. This is the best time. That's why I also want to make a video game. Okay. This is my other version of Unity. I don't know what this is. Okay. Because I want to create a simple 3D game with simple graphics. I need to pick up the 3D URP template. So which one is the 3D URP? This is the universal 3D. Is this it? This template includes the settings and assets you need to start creating with universal render 3D. Okay, this is the one. I don't need anything else. I'm just gonna create a project. We have not accepted the Unity editor, so yeah. Whatever you want, tchdy and everything. I'm joking, I wouldn't do this. I think I already did this once, and it takes some time, to be honest, to set everything up, which makes sense. We are dealing with meshes and objects and detections and rendering objects as well. How about making one of those popular 3D mobile games as a project? Yeah, I had sometimes you just need an idea. Like the guy who made Flappy Bird, the idea was to control the bird with your thumb. Yeah, that would be great. You just do you get those annoying ads? Like there's a guy shooting his gun, and you on the left you have like the multipliers, on the right you have zombies, so he needs to shoot the gun and the multiplier to get more of these guys, but the zombies are attacking him, and he always makes these stupid mistakes on purpose. I hate those. I hate those ads with a passion. Yeah, they produce them. Yeah, they produce them. What I really like is, I don't know if, okay, I'm gonna go on a tangent here. Sorry guys, if anyone is here for coding, I'm just gonna quickly Fallout. What's the name? Fallout. New Fallout game. Fallout Bakersfield. Yeah, this is the one. Wait. Wait.
Greetings to you all, ladies and gentlemen. For our first tune, I'd climb the highest mountain. If I find you.
Wait, let me. So I think this uses the Doom engine from Doom 94, and it creates a stylized Fallout game using the Doom engine, man. It's ridiculous. This looks amazing. Okay, I'm sorry. Apologies. I went on a tangent here. I didn't want to do this. Okay, so what this? This is this the big? Yeah, this is the welcoming screen. This is the welcoming screen. What do I have here? I have the assets. Show and explore. I think I already did this. Basically, these are just the assets that we have in our project that we are creating, like scenes, settings, stuff like that. I don't think it's important right now. Okay, so there's something called scenes in Unity, and what a scene is a type. Oops, wait, let me, where's my pen? Where's my pen here? Yeah, but it looks really nice, that Fallout game, and I think it's hope I'm not undermining the effect of multiple people. I think it's one guy working on it. By the way, one person built one of the greatest game, in my opinions, in the last 20 years. Stardew Valley. It's 150 plus hours of content made by one game. He did the sprites, he did the art, he did the music, he did the story, like everything. I was what the fuck? I was surprised. Okay, so what is a scene? A scene is one of the several types of files in our project. A scene can be used for different things according to the type of project. Where's my tablet? Here. I think I already wrote this. So scene is separating our game into sections. So in a simplified terms, a scene is, I don't know, we have here the main menu, we have here this is supposed to be a gun and he's shooting. This is level 1, level 2, and I assume a scene is grouping other assets together to create this structure, which is a scene basically. Okay. Yeah, pixel art is so great. I have a lot of wallpapers because apologies, I got a notification from my land owner, Unity neighborhood, stuff like that. They're organizing a meeting tonight. I'm not coming. I have a lot of wallpapers and I have some which are pixel art as well. I used to change my wallpapers every day. Now I stuck with this one. All right. So what is a scene? A scene is okay. We separate our game into scenes because that's the best way how Unity can process and load just the required data, which makes sense. Like, why would I load everything I have? So the data that we need will be stored in random access memory, which is the device's main memory. So all the other stuff is not needed. I don't need to load enemies and bosses of another level if I don't need it right now. That's why we also have loading screens as well. Okay. So we can load stuff like that. I like your accent, man. Thanks, man. I'm from the Balkans. I was born in Bosnia, but I was living also in Croatia as well. Thank you. I always thought I have a heavy Slavic accent. Give me 1 vodka and give me 2 cigarettes. Vodka and cigarettes. Hey man, nice to meet you too as well. Vodka and cigarettes. I'm sorry. Okay, so this is the Unity editor. This is the Unity editor. Morocco, Casablanca. Wait, is Casablanca in Morocco? Have I just said something really stupid? Casablanca city. Yeah, it's in Morocco. But wait, Casablanca is not the capital, right? I know that Rabat, yeah. I didn't notice. Yeah, I listen to a lot of German rap, and a lot of rappers are like Maghrebis. And he says, "Oh, yeah, I'm chilling in Casablanca" and stuff like that. That's why how I know this. Is Maghrebi the correct term? Like you are from the Maghreb area, right? Yeah, all Germany. I don't know Holland. What's the language Holland people speak? I don't know that language, but I know some German, and a lot of German rap is like Maghrebis and Amijas. When you open a Unity project, you will see the Unity editor. It will be composed of several windows or panels, each one helping you to change different aspects of your game. Okay. How do I I enter this? How do I I can zoom. I can zoom and I can move and I can do all of these cool things. So where's the scene? So this is the scene. This is the scene view, which shows us all the elements that we have. And it works on the principle of, how does it work? It works on the principle of, yeah, I can edit stuff here, right? I don't know how right now, but I can most probably edit stuff here. Okay, now I'm gonna add something. What's this? The Fusion tab in DaVinci Resolve. How is DaVinci Resolve? I'm using Linux, and I know that it's available for Linux as well, but I'm using KDE, which is an open source video editor. It's oh man, it's tough to work with. It's tough to work with, and I heard that DaVinci is even better than what's the name? What's the Adobe's video editor called? After Effects, right? Okay, so this is already an empty scene, but I want to create another empty scene. File, new scene. All right, so I have a new scene. Basic URP, a scene that works best with universal render pipeline. Contains a camera and a directional light. I mean, I already have an empty scene, but the tutorial says, okay, create just one more to know how they are created. Okay, once selected, click create. Wait, what if I create another one? New scene. Or can I set the name of the scene somewhere? No. No. But have I even created it? Basic URP. Where are the scenes? Guys, does anyone... I know this is a really stupid question. Does anyone know, should a scene... Is this a scene? Should another one appear here? New scene. Basic URP. Why has nothing changed? Or maybe it did. Maybe it did. All right. I created a new scene, I hope. Hopefully. Now, I want to create a game object. And I assume you can add external 3D objects and stuff, but for now, I'll add... I'm entering the game objects, drop down, I'm going 3D, I'm selecting the cube. So yeah, most probably I have other primitive objects. I'll most probably download 3D models once I start creating something. My game. But for now, the tutorial says, the, the book actually says, it's better to first try whatever you have with regular primitive objects, and this is called gray boxing or prototyping, right? I'm not gonna say. Yeah, I also think DaVinci has a better UI as well. It has a really cool UI. Again, I haven't worked with it. I tried installing it to Linux and it was painful like everything else. And it was buggy for me, but I would like, because I think After Effects it's damn expensive. Damn expensive. I know some of you younglings and me as well, we used to find these stuff in other places on the internet. But I mean, if you're doing it professionally, you need to have like a real After Effects. Do I use Linux? We had to use it on for some classes we had in university. I liked it, to be honest. I never worked in cybersecurity, and then my first job required us to work in Linux, not because it was a cybersecurity company, but they told us to use Linux because they were cheap. They didn't want to pay for any licenses. But man, Linux is picking up the pace. Even PewDiePie is recommending it. Navigating the scene view. Okay. I need to learn how to move through the scene to view the results from different perspectives. The first one, I can hold the right mouse button and I can use the arrows to move in the 3D space. Okay, what else? No, I clicked some. No, what have I clicked, man? Oh, okay, I didn't click anything. Again, I'm holding the right mouse button and I'm clicking Q and E to reduce and increase my height, to move up and down basically. How can I move an object? So I can click on an object and then I can focus it with F. So my scene is now directly focused on this object. And if I hold the right mouse, but no, this is not it. So I'm holding Alt and I'm holding now the left mouse button because I'm focused on this game object, so it just rotates. It focuses basically this game object here. I don't believe in privacy. No, I mean, I think some certain form of privacy should be God given to humans, like the privacy to be safe, to feel safe in your own home and stuff like that. I'm not talking like an American. I don't think that you should go that far. But yeah, I agree with that. Internet privacy, it's a techy subject. I mean, why am I not? Okay. Why am I? Okay, I'm rotating it around this. Okay. I can also manipulate the game objects. How? there should be a transform tool here somewhere. Ah, it's this tool. Or there is a shortcut. I don't want to learn shortcuts. I'm learning shortcuts by need. Also, why is the shortcut for the transform tool Y? Is it Y? Y? Yeah, it is Y. But why? No. Okay. Okay. So I selected the transform tool and then I can most probably... No, this moves the object. Ah, okay. So when I pressed transform, I got this gizmo in the object. So with the gizmo, we can modify different aspects of it. So I can change the position because this is in a three-dimensional space. So I can move my box. Wait, how do I? So I can move my box around in the three-dimensional space. I can most probably rotate it, maybe by, yeah. I can rotate my object, and I can most probably extend it if I, yeah, if I click on this dot right here. So the object is moving across the selected axis. If I select red, it goes, so this is the x-axis. If I select blue, which is the y, and there is also the green one, but the green one is on the other side. Okay, the object moves along the selected axis. All right, I know this. I also have, oh, I have another gizmo here in the top right of my screen. Computer graphics use the 3D Cartesian coordinate system. Oh, makes sense. This is like high school math. This is like high school math. So the red color is the x-axis. I just messed up my... How can I move? Can I move it somehow? No. No, I did something bad. I did something. I want to see this from... Where am I? Am I in a limbo? First of all, I'm gonna reset the rotation to be all zeros. All zeros. How am I here? I understand it now. I understand it now. Can I focus it again? Yeah. Oop. So what do each of these axes mean? We have the we have how can I move this? This is what I want. x. Ah, okay. So the z-axis is the forward vector. This is the blue one. It moves on the forward axis, whatever this means. The x-axis is the right vector, and it moves the object to left or right, right? And the y-axis is the up vector. And these are known as local coordinates, which means that we can, like I did just a couple of minutes ago, we can rotate it in a sense that each object can point to different I don't know, rotations according to the rotation. So the local coordinates are used for this in order to move elements and to position them according to local coordinates. In order to make sure I'm working with local coordinates, I select them here. Okay. I also have transform. I don't care about this. Let me skip. Okay. So what's this is really simple. I think I'm gonna, oh no, I'm gonna skip this. I'm skipping this. Just a second, please. Just a second. Oh no. Oh no, my phone just died. My phone just died. Okay, so our project is being composed of assets. A scene is composed of game objects. So how can we create an object to a composition of components? And what are components? Components are making game objects. And each component is in charge of different features of the object. Whatever this means. There are several components that Unity. Oh no. I apologize. There are several components that Unity already includes that solve some tasks. Right. So if I select this game object, if I select this game object, I have this inspector panel, and the inspector panel shows the properties of objects here. So if you need to guess what the inspector panel does, it shows the properties of objects, right? Right. But all right. All right. So what the inspector is here, it shows properties of the object, but not the object itself. It shows the properties of the component of the object, and the component of the object is, for example, the transform, and transform just deals with positioning the object in our coordinate space. That's one component. It holds the position, the rotation, the scale of the object. It's just a list of constant properties. Then I have What else do I have? The mesh cube and the mesh renderer. These two components are in charge of rendering a 3D model. The mesh renderer is rendering the 3D model, and the mesh filter, I think it selects the type of the object, I assume. And then I have the box collider. The box collider represents the shape of the objects, and it handles collisions between different objects. Okay. So I can edit the component of an object inside the inspector. So what I want to do, I'm clicking this tiny, I don't know if I can zoom this. Can I zoom this? What? Can I zoom this? No. No, I can't zoom this. So there's like a circle here. If I click on the circle, I can click on the cube, because the component that specifies which mesh will be rendered is the mesh filter component, and then I just click again, and that should be it. For some reason it looks like an egg. It looks like an egg because I scaled it. If I remove the scale, it's looking like a circle again. Okay, it's looking like a circle again. Okay, it looks like a sphere now. Can I use the move? Is this the move? Yeah, this is the move. It looks like a sphere now. So we can add a new component to our sphere, which is called rigid body, and the rigid body is gonna add physics to it. Okay. We won't do this now. So I have components, add. What? So add, I'm going to physics, and I'm clicking rigid body, and there's another component here. Okay. So if I hit play, if you hit the play button in my editor, so there's a play, a pause, and what's this step? So if I click play, oh, it needs to do some loading, it seems. What? It just fell. Just fell because I don't have anything here. It's just empty space. It's a vacuum. It's like a limbo. It's like a limbo. So I need to add another something, and what I'm gonna add is another 3D object, a sphere. No, not a sphere. Okay, I can use a sphere. I can just change it into a cube, and then I can transform it. I can make it thin, and I can move. How can I move it? Like this, and then I can move it like, no, this down here. And maybe I can increase it a bit. And now if I click play, I think we should see some. What? 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 Why did it jump like this? Wait. If I move it here and here, and now if I press play. What? Am I doing something wrong here? I I mean the sphere is colliding. Let me just maybe it's not my fault. Maybe I need to do something like this. Why? Why? Also, I'm gonna move the camera. How can I move the camera? Ah, the camera is here. So, no. I'm gonna move. No, just want to move it. The camera like here. And how can I rotate the camera now? Is this what the camera looks like? Looks at? Oh man, I'm such an idiot. Okay. So this is the camera. I'm gonna rotate the camera to look down here. And then I'm gonna... Why? Can I just take the camera and move? How can I just take something and move it? Shift? No, it's not shift. I want to move. The only thing I want is to move it. Is this it? View, move tool. Ah, it is. It is. So is my camera looking at these two objects? It should be. From a wide angle now. From far away. I'm a beginner, so I don't. There's no need of me like micro managing this. So if I click this again, okay. If let me focus my sphere. If I take a look at the box collider component of the sphere, what am I seeing here? I'm actually seeing that even though this is a sphere, it's actually a box as it represented in the physical world because it has these borders here. Okay, so we have also an explanation why this happens, because video cards can render highly detailed model. That's why GPUs are used for playing video games. That's their own use. Okay, GPUs do that, but the physics system is executed in the CPU, and the CPU does a lot of complex calculations in order to detect collisions. Ah, okay, that's why this happens. It assumes that we have a machine that doesn't properly handle collision shapes, so it creates these easy to calculate, easy to detect collisions shapes. So now we need manually, I think, we need to manually change this to be a sphere. So I have the box collider. Ah, so the reason why this happens is because this is a box collider. Okay, if I click, how can I remove the box collider? Remove component. I removed the box collider. What happens if I click play now? I think it's gonna just fall through the plane here. Yeah. I think it's gonna just fall through the plane here. Hey guys, what's up? What are you even doing? I'm just trying to set up this Unity thing. What game are you trying to make? I was trying. I will make. I'm just learning how Unity works. I will make. I don't know if you played Persona, but I want to make like a rich RPG like Persona, only in 2D, like completely 2D. It's gonna be like dialogue heavy. It's gonna have these different mechanics like I don't know, turn-based RPG battles, social stuff, blah 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 blah. Introduce yourself, brother. Hi, brother. My name's the Duke. You are late, brother. I was streaming for 2 hours. I'm almost done. My brain is fried. It's 9:30 where I'm from. Hey, Marcus. Yeah, I'm just learning Unity, man. I had like an hour ago. I did I did some machine learning thing, which was probably more interesting to you. I'm just setting. I'm just trying to see how Unity works. I don't think you're gonna learn something smart at least for another month. When I usually stream, Abdul Habibi, when do I usually stream? I don't know. After work, I try to hit it immediately after work at maybe 5. Uh, but sometimes I have extra work. Yeah, everyone has to start somewhere. Thanks, man. Thanks. I was bored um, of my work. I'm working as a software engineer, and I just wanted to make something fun because I fell in love with programming because I built games like I don't know, rock paper scissors or a basic version of chess or something like that. And now everything you do is like life draining. Yeah, it's 9:30. I'm from Bosnia originally, but I also lived in Croatia as well. Hey man, nice to meet you on web development. Hey, what are you working on? What technologies are you working with? Nice to meet you too. Would you like to do a live with me? Yeah, man, next time. Next time. We can do it on what technologies are you using? React, Angular? Are you doing front end? Are you doing like backend? What are you doing? Django or Node? I I started myself with Angular, and then I branched out to okay. Oh, these two are like the top technologies. I just wanted to give like a thumbs up for using React. I was mostly using Angular, and it's becoming too heavy with every new iteration. React is really good. It gives you a lot of freedom. Also, Django is amazing. Python in general is. I remember first. So I worked with C, C++. Then I started JavaScript. JavaScript evolved, not evolved. It like a moth. It grew into a butterfly. It became TypeScript, and all of them had like strict ways of writing your code, more or less. I mean, lately with TypeScript, you don't even need to close your line with a semicolon, but back in the time, you would get a syntax error. And then I tried Python, and I was thinking, man, why would someone use Python? You are graduating, Marcus. Then I thought to myself, why would someone use Python, man? Because it looks bad. I mean, it doesn't look bad. It's just until you get used to it, it feels unnatural. The way how Python works, and then it becomes, I think, the best language. Like it's so fucking amazing. It's so fucking amazing, and the libraries that come with Python, the speed. I know that the C developers are gonna shit on Python users because I don't know if it's true that like Python is mostly written in C, so it's by association slower because you need to build C and then you need to build Python code as well. Yeah, yeah. C++ is also great. C++ is also great. I mean, all of these languages are really, really good. Oh fuck, guys. It's late. I'm sorry. I need to end the stream early. Next time, I usually do the first half of the stream on machine learning, the second half on stuff like this, which are more like hobby stuff. So if you want to join, I don't know. Thank you guys for watching this. See you. Bye bye.